Now we're going to look at some special factoring patterns. So we have already discussed one, which was the difference of squares. So if you remember, the difference of squares is that if I have a squared minus b squared, it factors to a plus b, a minus b. Now, something really important to remember is the sum of squares is prime. We can never factor the sum of squares. There is no rule for factoring the sum of squares. It's impossible. Sum of squares is prime. However, when we deal with cubes, we can factor both the sum of two cubes and the difference of two cubes, okay? Squares, you can only factor the difference, but cubes, you can factor the difference and the sum. So the sum of two cubes and the difference of two cubes has a very similar pattern, okay? So a cubed plus b cubed factors to a plus b times a squared minus a times b plus b squared. And the difference of two cubes factors to a minus b times a squared plus a times b plus b squared. So you'll notice the only thing that changes are the signs. And what I want you to remember to help you remember where to put the signs is the word SOAP. Okay? SOAP stands for same sign as the original problem. O stands for opposite sign from the original problem. And then the AP stands for always positive. The last term is always going to be a plus. Always positive, always plus, however you want to remember that, okay? So if we look at this, we have the original problem has a plus, so we have same sign, opposite sign, always a plus, always positive. Same thing down here, minus, minus. We have same sign, opposite sign, always a plus, okay? I recommend that you write out the rule in terms of A and B for every single problem until you have it memorized. That's the only way you're going to get it in your brain. So instead of looking at your notes, practice writing it down over and over again so you can commit that to your brain. Now, an important thing to remember is that A cubed plus B cubed does not factor to A plus B cubed or A minus B cubed similarly, okay? We saw when we multiplied polynomials that the cube of a binomial comes from Pascal's triangle, and that gives us a completely different answer, okay? A plus B cubed is the factored form, and if I multiply that out, I get A cubed plus yada, 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 yada. If I were to multiply out the factored form here, I would get A cubed plus B cubed, not A plus B cubed. They are not the same thing, so be very careful. Remember, are you factoring or are you multiplying? Okay, the direction that you're going with the operation is really important. And then lastly, on the next page, I've got the first 10 perfect cubes listed out. You should recognize those 10 numbers as perfect cubes. So put them on a flashcard, start studying those perfect cubes. You should know those without a calculator, okay? All right, so let's look at a couple of these. Number 5, we always check first for a greatest common factor. This one does not have one, so we're good to go. And so I see two terms and subtraction. So first I'm going to say, are they perfect squares? Well, no, because x cubed is a cube and 125 is not a perfect square. Then I look, are they perfect cubes? And here I'm doing x to the third minus, you can see on the right, 125 is 5 to the third, okay? So that's our A and our B. Now let's write out the rule. This is how I build it every time. It's always A and B in the first factor, A squared, AB, B squared in the second factor. And then we do our signs. SOAP, same sign minus, opposite sign plus, always positive plus. So there we have it. Now we're just going to plug in x for the a's and 5 for the b's. So I get x minus 5 times x squared plus 5x plus 5 squared, which is 25. And that last factor is always going to be a quadratic that is prime, so we don't need to factor that further. It's never going to be factorable. So that's what we get. You can check, does anything multiply to 25 and add to 5? And the answer is nope, doesn't work. Okay, let's look at 6. Now this one does have a GCF to start. So we're going to start by factoring out 2x squared. That gives me 8x to the third plus 27. And now I look inside here and I see two terms with a plus. So the only thing possible is if these are perfect cubes, which lucky for us they are. This is 2x cubed plus 3 cubed. Again, use the numbers on the side table there to help you. And so the rule is going to be a squared, ab, b squared. Now we do our signs. Same sign, plus, opposite sign, minus, always a plus. So let's plug it in. Don't forget our 2x squared. 2x squared is still there. So now a plus b is going to be 2x plus 3 times 2x squared. Remember, you have to square the 2 and the x, so we get 4x squared, minus 2x times 3, which is 6x, plus 3 squared, which is 9. And that is our factored completely polynomial. As usual, I will ask you to pause your video and try number 7 and 8 on your own to see if you understand, and then come back in 3 seconds for the answers. All right, there's our answers. So number 7 is the sum of cubes. Number 8 has a GCF, and then we get a difference of cubes, which is exactly the same as one we did in number 5, just with a Z instead. So we already kind of had that one done. So pay attention, again, sum of cubes, difference of squares only. Never addition for perfect squares, okay? And there are how we do our sum and difference of cubes.